Hello everyone, welcome back to the channel. In this video, we are going to discuss about the concept of list in Java. So in the previous video, we have seen the introductory part of the collection framework in Java and what it is, and also we have seen about the stream API. Now here we will see how exactly we can use the collection framework and various interfaces and various data structures. Okay, so the first data structure we are going to see is the list. So as you can see, list is an ordered collection of elements. So what does it means that the order in which you add the element to the list, that order remains the same. Okay, so that's why it's called an ordered collection of elements. And since list is an interface, so there are two implementations of list. One is ArrayList and one is LinkedList. So ArrayList is basically dynamic array implementation. Behind the scene, it uses arrays to implement the list, and linked list is a linked list based implementation, or more specifically the doubly linked list based implementation. Okay, now there are two types of list. One is mutable list and another is immutable list. So depending on various situations, you can create mutable as well as immutable list. Both have their own benefits. Mutable list, in case you want to do more and more write operations, then you need a mutable list. And if the purpose of a method or purpose of using a list is just to read the data from it, then you should it is encouraged that you should use a immutable list. So we will see one by one how do we create it. So first we create ArrayList. Okay, so basically it is backed by dynamic array. So in this also we will see first mutable list. So we know that list is an interface, so we can create a list of integer. Okay, and we can say nums. Now here this angular brackets is known as the concept of generics. Okay, so it means that if you want to you should specify what data type the list will be storing. So I have mentioned here the integer, you can specify float, double, long, but remember that we have discussed earlier. If you go to our channel, to our playlist in the Java course, then in the variables and data types we have discussed about primitive and wrapper types. So primitive types are not supported by the generics. The wrapper types, which are the reference types, are supported. So it is most recommended that you use the wrapper types. Okay, if you want to know about all the classes we have discussed in this video, you can watch this video once again to revise variables and data types. So coming back here, since list is a interface, so we need to create a class of it. So we will create a class of ArrayList. Okay, and this is how we create an object. Right now we will add the elements to it. So this element is very simple. There are method add, so we can add 1. Okay, then nums dot add 2, nums dot add 3. Okay, so let's add 3 elements and we can simply print the list. So if we print the list, it by default implements the toString method, so we don't need to iterate it one by one like we do it in the arrays. So this is the beneficial of using the list. Okay, so here you can see we have got our list. Now this is how we are creating a mutable list. Let's create an immutable list. So immutable list. Okay, so immutable list can be created by various means. One of the most popular means is, first you create a list of integer. Okay, and then we name it nums2 or nums2, and then we say list dot off. Okay, off is a static method here, and you can specify number of elements. So 1 2 3 4 5. Okay, that's it. You can write as many elements as you want, so that's not a problem. So we have created a immutable list here, and now you cannot add into it, or you cannot do any write operation. Okay, you cannot remove anything, you cannot add anything. It is immutable. So what can we do? We can simply print it, and we can use certain methods on it. So we will see what methods we can use. So we have got a list here. Right now, let's explore some methods. So if you see here, we have various methods. One method is size. So this size method tells us about the total number of elements in the list. So let's print this and try to find it. Okay, sout and sout dot size. In the nums, we have 3 elements, so the size of the list is 3, right? And list also supports the indexing. So the index starts from 0, right? So you can, to access a particular element, you can write nums dot get. There's a get method, and you can specify, suppose I want to get the first element at index 1. So okay, so the element at first element is 2, because index starts from 0. So at 0 the element is 1, at 1 first index the element is 2, right? So this is how we can access the random elements. Then there is further methods. You can see here set. Now in the case when you are creating a mutable list, this set you can do it. So what set does it? It takes an index and it takes an element. So at a particular valid index, you can change the value of the element. So I want to change the value of element at index 1, and I want to change it to 10. Okay, and then if I print nums, you will see that currently our list is 1 2 and 3, but now it will become 1 10 and 3. Okay, so as you can see, we have successfully changed the list, right? Then there are further methods like contains. Okay, so contains method returns a boolean. So you pass an element that you want to find if it is present in the list or not. Suppose I pass 3. Okay, let's print whether 3 is present in it or not. So it will return a true. So these methods like size, get and contains, you can apply on the immutable list also. Okay, so you can get contains 5, but if you try to apply nums2 dot set and you try to change it to 10, suppose, then it will not allow it. It is giving, it says immutable object is modified, so that's not allowed. But and if you try to print nums2, it will not give you the compile time error, but it will throw an runtime error. So it throws an error, unsupported operation exception. So this confirms that this list is an immutable list. We will see more about immutable list in the upcoming sections, but for now the easiest way to create an immutable list is using the off method. Okay, so let's comment it out, because let's remove it, because this is not a valid method. So now next we talk about the linked list implementation. Okay, so linked list. So linked list is basically behind the scene there is a doubly linked list implementation. We will talk in detail about doubly linked list also, but for now, to get you an idea of it, so let's I just wanted to show you doubly linked list. So if you search for doubly linked list and go to this here, so you can see that somewhat this is the structure of this is the data structure. Okay, there is an element here, and it contains the address of the next element, and also it contains the element or the address of the previous element, and these are not the contiguous memory allocations. Okay, so in arrays there needs to be a contiguous memory allocation, whereas in linked list the memory allocation, each element can be present anywhere in the memory. So this is you can say a different type of implementation. So what is the benefit of it? So the benefit of it is that we don't need to pre-allocate a particular amount of memory. So it has its own benefits. If you want to add or insert more elements or delete the elements, those operations are more frequent, then the linked list implementation is more useful. Whereas in case you want to search or search the element, or you want to sort the element, or you want to get the element by index, so in that case the ArrayList implementation is more efficient. So let's see the implementation of it. So implementation, we will say let's say my list, okay, and simply we have to create a linked list class object, okay. So we can just say my list dot, it also has the same way like we have done for the array list, okay. And suppose these are the three elements we have added, and if we see my list, so if we run the code, we get 1, 2 and 4, right? And all the other methods that is implemented by the array list here is there, you can do it, okay. Now if you come to the documentation part, so here you will find that there are lots of elements. Now you can see here is an element add, okay, which returns nothing, but it inserts the element at a particular index. So there is a difference between this add method, which inserts the element at particular index, and there is one more method which is set, okay. So basically set elements change the existing element, changes the value of the existing element at a particular index, okay. Whereas the add elements don't replaces any element, it inserts it. So I'll tell you the difference, okay. So suppose if I say my list dot set, okay, and I want to change this value to 10, okay. So what will happen in the my list? If you see now, from 1 to 4 it will become 1, 10, 4, right? So this is how the set method works. But let's say we don't want to do set, we want to insert add. So if we do this, now you will see that at the index 1 the element will be 10, and the 2 will be shifted to index 2, and 4 will be shifted to index 3. So now you will have the elements 1, 2, 1, 10, 2, 4. So if you run this, so you get this, okay, 1, 10, 2, 4, right? So this is the difference between the add method and set method, which has the same signature. So just go through this documentation. I will give the link of this. It is very important that you get this documentation, okay. And similarly, this is the index of method. Index of method gives you the first occurrence of a particular element. Similarly, the last index of gives you the last occurrence of any element, right? So basically you can use all these methods. Then you can create a sublist also from a particular index to another index. You can sort the list, and you can convert the list to array. So some of them, let's see it, okay. Sorting and all, when we have to do it, we use a special class called collections class, or we use a comparator. So both we have not discussed yet, but I'll just tell you how it is done, okay. So first way to sort is sort first way. We can use a collections class, collections, okay, collections class, and it has a method which is sort. You have to just pass your list. So if you pass your list my list and then print my list, so it will sort the array, sort the list. So from 1, 10 to 4 it becomes 1 to 4, 10, right? If you want to do it in the decreasing order, then you need to pass a comparator, okay. So if we see the comparator, okay, comparator, okay, let's go to the comparator. So comparator is a functional interface, and from the video earlier we have discussed about this functional interface here in the lambda expression, right? So you can watch this video to know more about the comparator, to know more about the functional interface. So basically we can use a lambda expression here, and it has one abstract method, that is compare. So it returns int, an integer value, based on what? So it returns positive value when the first argument is greater than second, negative when first is greater than is smaller than second, and if both are equal, it returns 0. It is a topic that needs a dedicated video, so we will cover it in the later course. But for now, what you can do is you can do it like this: collections dot sort, and then pass the list. If you want to sort in a reverse order, just say comparator dot reverse order. That's it. So it will sort your list in the reverse order, right? And if you print it, then you can see 10, 4, 2, 1, right? There is more better approach to doing this. So what you can do it, you can directly call this sort method on the list itself. So my list dot sort, and then pass the comparator. So comparator dot reverse order. This does the same work, but in a more readable and more logical way. Okay, rather than using a collections class, you can use the sort method directly on the list, right? So let's comment it out and let's run this method. So it gives you the same output, right? Now this collections class also is a kind of utility class for all the for various collections. Okay, it has lots of methods in it, so we will explore them one by one. One of the thing that I want to specify is that is empty list. Okay, so if you say collect system.out.print collections.empty list, it will return an empty list. So in case if you get a result where if you are expecting a list of suppose some data and there is no data, so rather than returning a null value, you can return an empty list. There are various ways also to return an empty list. You can do it like this also, list dot off. That's it. So it also returns a empty list, but remember that this is an unmodifiable list. Okay, immutable list it returns. So depending on various use cases, you can try out these methods and use these methods on your own, right? We will see a lot of exercises also based on it, but for now the purpose of this video is to get you introduced to this list interface and how it works and what are its implementations. So we have seen the two implementations of it, ArrayList and LinkedList, and we have seen the mutable and immutable list, right? So that's all for this video, and I hope you have understood at least the fundamentals of the list. In the upcoming videos, first we will cover each of the data structures or each of the interfaces that is implemented by or that represents a particular data structure, and then we will deep dive into how we can use various methods, and we will tackle a particular problem to solve those things. Okay, to understand all those things, don't worry about it. Okay, so that's all for this video. I hope you have understood it. If you have liked the content, please press the like button, and if you are new to the channel, please subscribe to the channel. So I'll see you in the next one. Till then, bye bye.